Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, let us see about different types of analog to digital converters. So basically, analog to digital converters are divided into two types, direct and indirect ADCs. So if an ADC performs the analog to digital conversion directly by utilizing the internally generated equivalent digital code for comparing with the analog input, then it is called as direct type ADC. If the ADC performs the analog to digital conversion by an indirect method, then it is called as indirect type ADC. So in general, first it converts the analog input into a linear function of time or frequency, and then it will produce the digital output in the indirect type ADC. So direct type ADCs are say successive approximation ADC, flash type ADC and Delta-Sigma ADC. Whereas under indirect type, it comes the integrating ADCs like single slope, dual slope ADC and pipeline ADC. So let us see about successive approximation ADC and flash type ADC in this video. So this is the block diagram of successive approximation ADC. So the successive approximation ADC is one of the most commonly used type of ADCs. So it converts the analog signal into a digital signal by using a binary search algorithm. So the conversion process involves a comparator, a digital to analog converter, and a successive approximation register. So the working of the successive approximation ADC is like the control logic resets all the bits of the SAR and enables the clock signal generator in order to send the clock pulses to the SAR when it receives the start commanding signal. The binary data present in the SAR will be updated for every clock pulse based on the output of the comparator. So the output of the SAR is applied as the input to the DAC. So the DAC converts the received digital input, which is the output of the SAR, into an analog output. So the comparator compares this analog value VA with the external analog input value VI. So the output of the comparator will be a 1 as long as VI is greater than VA. Similarly, the output of the comparator will be 0 when VI is less than or equal to VA. So the operations mentioned here, it will be continued until the digital output is the valid one. Some of the advantages of successive approximation ADC are its speed and resolution, and its efficient power utilization, and it is used in battery suitability where it suitable for battery operated devices due to low power consumption. Some of the applications of successive approximation are used in data acquisition systems, portable measurement devices, etc. Next one is the flash type ADC. So the flash type ADCs are the fastest type of ADCs using a parallel architecture to convert the analog signal into a digital signal in a single step. So it consists of a series of comparators that compare the input voltage against the reference voltage. So the 3-bit flash type ADC diagram is shown here. So which consists of a voltage divider network, 7 comparators and a priority encoder. So the working is as follows. The voltage divider network contains 8 equal resistors. A reference voltage VR is applied across that entire network with respect to the ground. So the voltage drop across each resistor from bottom to the top with respect to ground will be integrated integer multiples from 1 to 8 of VR8. The external input voltage VI is applied to the non-inverting terminal of all the comparators. So the voltage drop across each resistor from bottom to top with respect to ground is applied to the inverting terminal of the comparators from bottom to top. At the time, all the comparators compare the external input voltage with the voltage drop present at the output, respective other input terminal. This means the comparison operations take place by each comparator parallelly. So the output of the comparator will be a 1 as long as Vi is greater than the voltage drop present at the respective other input terminal. Similarly, the output of the comparator will be 0 when Vi is less than or equal to the voltage drop present at the respective other input terminal. So all the outputs of the comparator are connected together as the input of the priority encoder. So the priority encoder produces a binary code which is the corresponding to the high priority input that has 1. Therefore, the output of the priority encoder is nothing but the binary equivalent, or say the digital output of the external analog input voltage Vi. So this is the working of the flash type ADC. So let us see the advantages and disadvantages of flash type ADC. So the advantages are it converts the analog signals to digital in a single step, ensuring rapid processing. So it's fast conversion, and it utilizes the multiple comparators simultaneously for efficient signal conversion. So you can say that it uses a parallel architecture, and it achieves conversion without intermission steps, enhancing speed and simplicity. So it is a single step process. Some of the disadvantages are it consumes more power. So it has high power consumption. Next one is it's a complex design because it uses many comparators and parallel architecture. Next one, and cost of this flash type ADC is very high. Uh, so hope you understood the types of ADCs, especially successive approximation and flash type. So let us take up some assessment questions. Which type of ADC is known for its high speed and parallel conversion? So as you know, it is the flash ADC. Which ADC type utilizes a comparator and a DAC in a feedback loop to approximate the analog input? So as we saw in the block diagram, the successive approximation ADC uses a comparator in the feedback loop to compare. Next one is, what is the main disadvantage of the flash ADC? So the main disadvantages here is high cost. Uh, so thank you for watching this video.